right, so what we are looking at today is some certain types of polynomial functions. We want to be able to identify polynomial functions, we want to be able to graph the polynomial functions, and we want to know what's going to happen with their end behavior. We're also going to take a look at some tables. So a polynomial function is just a monomial or a sum of monomials. So when I'm talking about that, we're saying like x to the fourth plus x squared minus 2. That's a polynomial. We've been talking about those. A polynomial function should be written in descending order, so we should put the highest power of x first, then the next one, all the way down to the constant. A sub 0 is going to be the constant term. It says the exponents are always going to be whole numbers. They have to be whole numbers, and the coefficients are real numbers. Whole numbers are numbers 0, 1, 2, ... So no negative numbers in the exponents. The end behavior tells us the behavior of the graph as x approaches positive or negative infinity. We're going to be looking at that. And then the degree is always that highest exponent in that polynomial function. So we're going to start off, we're going to take a look at this. I just asked you to take a look at y equals x to the third. Did that look like A, B, C, or D? It looked the most like A is what it should have when you did y equals x to the third. So if we have a degree that's odd, meaning that we have, I could do any odd exponent. So let's do y equals x cubed, let's say plus 5x. If I graph that, I had an odd degree and I had a positive coefficient. Here is the way that it's going to look. Now it doesn't have the same curvature in the middle, but it has this end behavior. As x gets smaller and smaller, goes to negative infinity, y goes down to negative infinity as well. As our x's get larger and larger, y goes to positive infinity. So this is the general shape anytime we have this odd exponent. Give me another odd number. Okay, I heard 11. This should look the same way. Now what's going to happen though is that it's going to flatten out there in the middle, but it still has that same end behavior. Okay? All right, now what if we have an odd degree, but the leading coefficient is negative? So that means that in front of this x to the 11th, what if I were to put in a negative? What do you think that's going to do to the graph? Flip it over the x-axis. So here's the way this is going to look then. So it's going to be going down instead of up. See how it flipped it? So when we have an odd degree and a negative coefficient, y is going to go to infinity as x goes to negative infinity. What this means is as x goes down this way, y is going up. It's also saying that as x gets larger and larger, y is going to go down to negative infinity. Are you understanding this notation? F of x means what? Y. So this is saying y is going to infinity when x is going to negative infinity. All right, let's change our degree now. So give me an even number. Let's go with 4. I'm going to change it to I want a positive leading coefficient. All right, so let's look at this one now. It should look like this because we put in an even degree and a positive leading coefficient. When we graph it, here's the way it looks. So what it's saying then, as x goes to negative infinity, y is going up. As x goes to positive infinity, y is going up. Here's another way we can put this. What happens at the end down here? Are we going up or down? So this would be a down-up function at the end. Okay? What would this function be then? Up, down. What would this one be? Up, up. And this one? Down, down. So if I have a function and I just make this leading coefficient negative, let's see how that's going to look. See how now it's going down, down because we have an even exponent and a negative leading coefficient. All right, so we already did this testing out. Let's go over here now. Decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. All right, is this in descending order? So it's not in standard form. To put it in standard form, I need to put the x to the fourth first, then the x squared, and then the x, and then the 1. To see if it's a polynomial function, I have to have all whole numbers for the exponents, and we do. If we want to say the type, this is to the 5th power. This is called a quartic. When our degree is to the 4th, this is a quartic function. And what's the leading coefficient? So this would go what? Up, down, 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 up, down, what? Down, down at the ends. Good. All right, this one. Is this a polynomial function? No. What is this power of x to? -1, actually. This could be rewritten as 7x to the -1. That is not a whole number, so this is not a polynomial function. All right, on this one, this x is not under the radical. This is outside of the radical. So we have to meet the requirements of having whole numbers for exponents, and we do. We also have to have real coefficients. Is this a real number? What type of number is it? Irrational, but irrational still is real. We can't have imaginary, so I couldn't have an I there, but I can have a radical. So this would be yes. Anybody know what type if it's just x to the first? Linear. All right. The next one, put it in descending order. It's going to be -2x squared plus 3x minus 2 radical 3. Check the exponents. They're good. They're whole numbers. Leading coefficient. Forgot to do that on the last one, but that's okay. Leading coefficient here is -2. And what type if it's to the 2nd power? Quadratic. All right, and how would this go, by the way? Would it go up, 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 down, down, down at the ends? Okay. Evaluate the function for the given value of x. How's the quickest way to plug in 2 into this? Synthetic, guys. Synthetic division will tell us the answer when we plug in 2. Whatever we get for the remainder, that's the answer if we were to plug in 2. So we're going to bring this down. This is -2, add. This is 8, add. This is 10, add. So what's the answer then? So I would say h of 2, meaning when x is 2, when I plug in, we get an answer of 14. Yep, -8. Thank you. -11. -22, -18. All right. Okay, so on this one, it says to describe the end behavior of the graph of the function. It's to the 6th power, and we have a negative leading coefficient. What does that mean it's going to do? Down, down. Now, that's correct, but the more mathematical way of writing this is f of x goes to -infinity as x goes to -infinity. F of x goes to -infinity as x goes to +infinity. Let me break that down. When we're going far, far, far in the x direction, y gets lower and lower. As x gets larger and larger going that way, y is going to -infinity. That's the way we write down, down. Okay, looking at this one, what's our degree here? What's the degree, guys? 5. So that's an odd exponent. So do we do the same things at the end or opposite? Opposite. I always think odd, opposite. See how you just flip those over? Okay, so that leading coefficient is positive. What's it going to do at the end then? It has to do opposite, so it has to be either down, up, or up, down. Down, up. Let's think of how we write that then. F of x is going to, oops, I need an arrow, not an equals. F of x is going to negative infinity as x goes to what? This is the beginning, so this would be as x is going that way. What's that for x? That's negative infinity. And f of x is going to positive infinity. This is this end. Right, as x goes to positive infinity. So this is saying y is going down at the beginning, y is going up at the end. You always have, this is when x is going that way, this is when x is going that way. All right, what do we know about the degree of this? Is it even or odd? So the degree here must be odd. Would the leading coefficient be positive or negative on something like this? Negative. Do you guys know how we know that? Because it's going like this, right? Opposite means odd. Normally the odds go like this. So if it's flipped, it has a negative leading coefficient. All right. Sketch a graph of the polynomial function f if f is increasing when x is less than negative 1 and it's increasing between 0 and 1. F must be decreasing when x is in between negative 1 and 0 and when x is greater than 1. Also, f of x has to be less than 0 for all real numbers. This is a lot to decipher here. First of all, what does f of x mean? Y. So this is saying y always has to be less than 0. So I am always going to have to stay below this x-axis if all my y's must be negative. Now, it says my function has to be increasing until I get to negative 1. So what does increasing mean? Going up. So until I get to negative 1 for x, I have to be going up, okay? Between negative 1 and 0, when x is in between negative 1 and 0, what do I have to do? Be what? Decreasing. I don't know how far down it goes, but I know it has to go down, right? Between an x value of 0 and 1, what am I supposed to do with the function? Make it do what? Go increase. And then what's it supposed to do when x is greater than 1? Decrease. That's the way that function is going to look, something like that. We had to stay below the x-axis, and we had to follow that increase-decrease. It says to describe the degree. What's the degree have to be, even or odd? Even. And what about the leading coefficient, positive or negative? Negative. All right. Not sure I'll have time to get through this one, but let's see how it goes. The number of students who graduate in 4 years from a university can be modeled by this function. I'm going to put it in. Okay, so it says use a graphing calculator to graph the function from the interval from 0 to 5. So I'm going to go to my window, and I'm only graphing this between x equals 0 and 5. This is the number of students in thousands who graduate. I'm going to need this y max to be pretty big. I don't know how big. I'm going to make it 200 to start. All right, here's the way the function looks. Not that exciting, really. Okay, describe the behavior on the graph of this on this interval. I'm going to make this a little lower so we can see it better. Okay, so it's just barely going up, and then it starts going down. So it's kind of like this behavior. All right, that's all we have to put for the behavior. What is the average rate of change in the number of four-year graduates from 2010 to 2015? I need to get those answers, so I'm going to go to my table, and I'm going to find at 0, we are at 23, and at 5, we're at 16.7.